Hello, I'm Brian Fung, and I'm the first speaking for Team 7. For our project, we decided to create a malware Android app that encrypts the data of its target device. In order to do this, our plan for the application was to get access to all Android files and encrypt the files using built-in Android functions with encryption methods like AES and DES in order to hold it as ransom. However, Android has made root access a requirement to modify any of the important root files on the phone. So instead, we've exploited a UI block to achieve a similar result. First, I wanted to talk about the application UI we're using to deceive the user into downloading it. Our application disguises itself as a phone cleaning app using a basic visual hierarchy that is easy to interact with and understand. Brendan will explain more about it from here.
All right, so the main philosophy behind our UI is to appeal to the common user who may or may not have as much technical knowledge as a student in this class may have. As a result, we went for simplicity when designing the UI. Explain some of the design principles. The rule of thirds is a visual composition technique seen in photography or filmmaking. We utilized it here to organize components in an aesthetically pleasing manner. We also made sure not to clutter the screen with too much technical information, but just enough to give the user a general idea of their phone's current state. From here, we created utility functions that calculate the current amount of used and available space for storage and memory. These are represented in bytes, which we then convert to a human-readable unit, which then are placed into placeholder text boxes represented by underscores.
Hello, my name is Brandon. I'm going to talk about the Android memory. The Android memory is separated in internal memory and external memory. In the internal memory, we could find the operating systems and the apps. The Android system uses a Linux user-based protection that isolates the apps from each other. So if you install that has a malware, it won't affect the other apps or the operating system. And the user can access this internal memory. And also, when you uninstall an app, every file of the app is erased. On the external memory, we'll find more data about pictures, photos, any file that you save that is not related like internally to the app. On Android 10 and up, the Android was changed because in the past, apps could access any external memory if they wanted to access it. But for Android up and higher, you had to ask permissions for every single storage, such as pictures, audio files, and videos.
Hello. My name is Thompson and I focused on permissions. Permissions are a fundamental part of any application that needs to interact with the phone. With permissions, apps may gain access to user information and even browse certain files that are not related to the app itself. However, many of these permissions must be requested of the user, and if the user were to decline any of these permissions, the application would not be able to make use of some of their functions. In our app, we made use of the following permissions: system alert window, read external storage, read SMS, and receive boot completed. Most of these permissions are asked for when the user clicks on the optimize phone button. But if the app already has these permissions, then it will activate some of the functions we gave it. The app asks for these permissions by either bringing up a message that the user sees, or it will bring you straight to a settings screen in which the user must manually allow the application to use the permission. As Android updated, Google realized the dangerous usage of permissions, and so they tried to limit permissions with each major update. For example, storage and user location permissions were restricted in Android 10. In Android 11, they made the system alert window clearer by forcing users to choose the application that they are granting this permission to. Essentially, permissions are a user vulnerability that gives apps too much control over a device if the user is naive.
Hi, my name is Nan, and I'm in charge of the blocking mechanism. For the blocking mechanism, we use the partial permission system alert window as Thompson described from the user. to enable emergency notification window and block them from accessing the phone. Emergency notification window is something that like you receive when there's an earthquake or like the police want to send you something, a notification about a thief or like a missing person. Because like this blocking mechanism do not violate any Google malware policy, since we do not contain any malware code in our application. We technically can post it on Google Play Store without an issue. However, different from auto blocking mechanism, this cap blocking mechanism does not like harm any information from the user. It just block the user from using the phone. And if the user want to like have their phone back, they need to factory reset it. It means like they need to reset every information and like back to the factory setting.
Hi, my name is William Pham, and Firebase is a cloud-based storage solution from Google. It's a crucial component of our ransomware app, as it is what allows us to extract, store, and essentially leak the victim's SMS, text messages, and photos to the internet. We chose Firebase over other alternatives because it's relatively simple to implement and it's scalable. In the case we receive a sizable amount of traffic. To implement Firebase, we simply needed to add the dependencies listed here on the slides to our Gradle build. To capture existing text messages within the victim's device, we needed to access the MMS SMS database file. The issue here is that the file is located under the /data directory, and that's located in the internal storage, which can only be accessed with root access. This is difficult to achieve with our current capabilities and time. Luckily, Android has content providers, which are interfaces that help applications access and store data from other applications. Android 4.0 introduced the telephony content provider, which can read existing text messages. So essentially, the read SMS permission, and with the telephony content provider, we just query each SMS object, filter out the actual message and the phone number, write that to a text file, and finally upload that to our Firebase.
Hi, I'm Frank. As far as image capturing goes, the permission we need is read external storage. The directory we use for the images, at least for the memory card, is sdcard/dcim/camera. As for the phone memory, that's emmc/dcim. So how this function works is if the directory exists, that means the user has images, so it loops through each file inside the folder and uploads it to the Firebase cloud. It follows the same storing procedure as SMS capturing. As you can see on the screenshot on the left, the top portion of it shows the path. The first item is our storage domain. The second item is the unique device identifier. That's where you can find the SMS messages. Then the last item is our images folder, where you can see all the images that we've captured. Reverse shell functionality. So this code mimics a GitHub gist by Casey Dunham. Pretty much just consists of two functions, which is reverse and execute shell. It actually runs on a separate thread to run alongside the other components of our application, such as the SMS and image capturing. The first function is reverse, which initiates the connection with our machine using port 4444. Then, if that connection is successful, it continues with execute shell, which allows us to use Android shell from system/bin/sh and allows for commands to be used and communication between the user and our machine. So on the screenshot on the left, you get a preview of what that looks like. How it works is when we type in a command such as who am I, change directory, or list, it sends that command to the device, runs, and then whatever output comes out from there gets sent back to us for us to view. This is the last phase of the malware.
Okay, I will continue with the future of the application. Reverse shell only work for on a local network and requires some more experiment. So, and if like we would develop this project further, we need to like have a connection to implement the reverse shell into our local application, and would require some port forwarding, allow connection through firewall to work from anywhere and anytime with any phone, and like of course with iOS, not only Android. Config function to be persistent reverse shell. Android security mechanism block a lot of functionality from the shell. So that like we need to find another like exploitation to penetrate through it. And further, we need to expand the data extraction. So now we only SMS and the image. But like in the future, if we possible, we want to have like private information like email address, password, and other thing. Crawler like functionality can go through user file and steal any sensitive data file it. But like there's no implementation possible to implement it into a application. And if like we want to make a UI user interface functionality more beautiful so that like it's more attractive to user, the permission asked at the start of this app are potentially suspicious. So like we want a kind of eliminating it to user without knowing context what they are doing. And with more time, more future, and asking permission convincingly, share app link with friend SMS example, you need to enable this permission for cache and clear. So for example, in the future, if like when we have access to a user phone, we will automatically send a link to all of their all of their friend and all of the phone number that have in that, so that like we can spread our malware automatically to the entire world. And Frank will continue with a demo to our actual app. Okay, Frank, try to close it. Try to close the font. Like yes, okay. Try to interact with it.
Yeah, can't do anything.
Okay, turn it on again. Turn it on again. Like turn it on again. Yeah. Okay. Cool.
So here's the Firebase. This is the device. Here we can see two text messages. An example of that would be this right here. Then the images are found in this one. As for the Linux, we've established a connection